When you're choosing a database you're going to use in your next project, it's good to make wise and informed choices. ObjectBox is a very fast NoSQL local database for Flutter and also for native Android and iOS with an intuitive API, rich support for queries and relations, plus you can optionally keep the database synced across multiple devices without any hassle on your part. This whole tutorial is actually brought to you by ObjectBox. Their local database packages are completely free and open source, and they are extremely pleasant to work with. As always, I only work with companies whose products I personally believe in, and ObjectBox is precisely that kind of a great product. Hello, welcome to ResoCoder, where you're getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to build a shop order application, which is going to show orders of respective customers, as you can now see on your screen. You're going to learn a lot: setting up of entities, relations, ordering of data, reactive queries, and all of this cool stuff. First, we're going to focus only on the local database functionality. And then at the end of this tutorial, I'm going to show you just how easy it is to sync your data across multiple devices with ObjectBox Sync. So the app we're gonna build is gonna look like this. Again, at first, it's going to be purely a local database, but then we're going to also sync the data across multiple devices. So what's gonna happen is that now, and inside this app, I can add new orders like this. And as you can see, because we are already using sync in this already finished app, these new orders display both on the Android emulator and on the iOS simulator simultaneously. So that's extremely cool. I have a local ObjectBox Sync server running on my machine here. So we can add new orders, and it's going to add orders for a customer. In this case, the customer is called Joe O'Hara. We don't have any real input forms for the name of the customer and for the price of the order. We are just using a package called Faker to generate fake names, fake prices, and all of that, so that we do not need to worry about user input. We can change the customer for whom we are adding the orders, or who is making the orders, to be more precise, by pressing this other button on the app bar. So this is going to change the name of the customer for whom we are adding the order. So boom, now the order is added for Dr. Brooks Stauber, And of course we can do the same on iOS. Change the customer, boom. Then we can also delete individual orders. For example, here for Howard Gulowski, delete that. That's also possible. And we can also sort these orders based on their ID. So either ascendingly or descendingly, and also ascending and descending sorting is available for the price as well. Lastly, when we tap on a customer name, for example, this Soledad Collins, we're going to see only the orders made by this precise customer. This is something where we are going to use relations, which ObjectBox supports, so they're going to come in very handy. Also, we can show all the orders for Vern Dibert, like this. We're going to show them in a modal bottom sheet. And the underlying widget which we are using here, which takes up this whole screen, is called Data Table. This is a core Flutter widget which we are going to be using. You don't really need to know everything about the Data Table widget which comes with Flutter in order to follow this tutorial, but I would recommend you to still check out the Data Table documentation from the official Flutter docs, just so we are on the same page. Actually, all of the links to different kinds of documentations and all of the code is available from the link in the video description. Over at that link, there is the whole written tutorial which accompanies this video tutorial on YouTube. So over there you can find all of the code written in this video, all of the links, and overall go through this lesson at your own pace. Additionally, from the written tutorial, you can also grab the starter project, which is going to contain the following code so that you do not need to start completely from scratch. And we're going to only focus on ObjectBox package in this tutorial. So the starter project contains this main file, which sets up the home of the material app to be a home page. This home page is just a simple stateful widget, which depends on Faker. And then this stateful widget contains a app bar with two icon buttons, which look exactly like these two icon buttons. And then it has an order data table, which currently doesn't show anything. It's just a placeholder. This order data table already has a callback for sorting, but again, we are going to implement all of this in this tutorial. And then also from these two icon buttons on the app bar right here, we are calling the set new customer method and also add fake order for current customer methods. And you could see them already demonstrated what they do right here. Currently, they don't add any customers and don't add any orders. They just print something to the console using Faker. But we're going to use precisely this faker.person.name to generate a customer name and then create a customer object and then put it to a database. For now, we are just printing everything. We just have placeholder code everywhere. As for the order data table, which is where all of the data will be displayed, all of the orders, it currently looks like this. So again, I would recommend you to check out the official documentation from flutter.dev for data table if you are not completely familiar with this widget yet. But anyway, this data table has a onSort callback, which we are calling whenever we press on the individual columns. As you can see right here, when we press on this column, the onData column sort callback will be invoked, and we're going to implement that data coming from the database will be sorted based on either ID or based on its price. So that would be it for columns. They just define the number of columns and the name of the columns, but the actual data, all of these orders are going to be displayed in rows, in data rows. In the actual app, once we implement it, the data row will contain the ID such as 13, then the customer name such as Alva Bayer, then the actual price. But for now, we just hold placeholder strings in all of these data row data cells. But this is where the actual data coming from the database will go. And also when we press the delete data cell, we should delete the order from the database. And lastly, tapping on the customer name, as you can see here, should show the modal bottom sheet and display the tapped customers orders. Again, this starter project is available from the link in the written tutorial. And now that you know what kind of an app we are going to be creating and where you can get this starter project and how it works, let's start implementing the app. Firstly, we need to add dependencies, and there's going to be a bunch of them. So let's open up pubspec.yaml and make sure that your SDK version of Dart is 2.12.0 so that you have the non-nullability support. And we are already depending on Faker, which actually is already available with version 2.0.0. Then we'll also need to depend on ObjectBox, ObjectBox Flutter libs, and path provider for the regular dependencies. So let's add all of these dependencies in here like this. So currently the ObjectBox version we are going to depend on is 0.15.0. The same goes for ObjectBox Flutter libs. Very soon there is going to be the version 1.0.0, and this 0.15.0 is fully compatible with the first stable 1.0.0 version. So even if you go to pub.dev like this and search for ObjectBox, and you're going to see that there is the 1.0.0 version, that's completely fine. This tutorial is still going to work with that version. Also, links to ObjectBox are in the video description, and to all of the libraries, there are always links in the written tutorial. We are using path provider because we need to be able to point to a directory where it's safe to store persistent data on either an Android device or an iOS device. And path provider will allow us to get that directory easily. Then for dev dependencies, we're gonna depend on build runner because ObjectBox works with code generation, and then we're also going to depend on ObjectBox generator. If you now want to be typing out these dependencies manually, you can always grab this code from the written tutorial. The dependencies have now been successfully gotten, and I would like to start the app we are currently developing right now. But before we can do that, we need to go ahead and edit the native iOS project if you are developing for iOS and you are on a Mac. And also, since at least I am going to be using the ObjectBox Sync to sync between multiple devices at the end of this tutorial, for sync, I also need to bump the minimum Android SDK version to at least 21. If you are not using sync, you'll not need to bump the minimum Android version, but if you are, it needs to be at least 21. So let's go ahead and do that. We are going to start with iOS. So again, this only applies to you if you are on a Mac and you are developing for iOS. If you're not, feel free to skip this section. So I'm going to right click on this iOS folder and say open in Xcode. Here we go. And we're going to need to bump the minimum iOS version to at least iOS 11. This whole Xcode UI is very small, so I apologize if you cannot see everything properly on YouTube, but we need to go to runner here, then targets runner, scroll down, and somewhere in here, if we go to build setting actually here on this tab above, we're going to scroll down and we will see iOS deployment target right here. So you want to edit this bit and set it to iOS 11.0. So this is the minimum version which ObjectBox supports. And then additionally, we'll need to go again to runner, but not targets runner, but project runner. And here, let's again select build settings, select all, so that we see all of the settings. And we're going to edit all of the way above this architectures bit. So click on this architectures, and ObjectBox supports only 64-bit architecture. That's completely fine because all of the iOS devices, whether iPhones or iPads, from the last few years already support 64-bit architecture. But still, you need to indicate that to the native iOS project by changing this setting in Xcode. So click on this architectures value and select other. And now we want to replace this arcs standard, so double click it. And we instead want to write here $ and then all caps arcs underscore standard underscore 64-bit. And now you're good. So you can click away, and the architectures are now going to be standard 64-bit. With these two steps finished, you can now run the app freely on iOS, and it's just going to work. So we can close the Xcode. But what we also now need to do, at least I need to do it because I'm going to be showing you how to work with ObjectBox Sync toward the end of this tutorial, is to go to Android, App, and then build a Gradle here. And I'm just going to bump the minimum SDK version to 21. So at least I need to do this. You may not need to do it depending on where you are using Sync or not. With this out of the way, let me actually bring the Android device here so that we're going to be developing on Android throughout this tutorial. And let me run the app on Android. So currently there is not going to be any data displayed because we are still using just the placeholders from the starter project, but we are going to change that fairly soon. So this is how the starter project app looks like. It contains the data table, it's clickable, we can sort of sort based on the number and on price, but it doesn't really do anything because the data is just placeholder hard-coded string values. Also, when we tap on changing this customer icon and open up the debug console, we're going to see that we have printed Amia Johnson and Miss Chloe Murphy 4th for some reason, right? And also when we add a new order, we are going to see its price, which is randomly generated using the Faker package. So we're shortly going to use this to actually create customer objects and order objects that are then going to be put into the ObjectBox database. By looking at this, let me just change this number column name to say ID. So let's go to order data table, and here in the data column where it says number, let's change this to ID. So let's first create the classes that are going to be created and then put into database instead of just printing these messages into the console from the home page methods set new customer and add fake order for current customer. ObjectBox worked with entities. These entity classes allow you to work with just nice regular Dart objects from your Flutter app, and then it's the ObjectBox's responsibility to take these nice Dart classes and convert them to something which is then stored in the database. But as for you, as for the end developer, you do not care about how the data is really represented on the database, and that's the beauty of it. So you can just work with nice regular Dart classes. We're going to have two of them in this project. One is going to be a shop order and the other one is going to be a customer. So let's create under the lib folder a new file, call it entities.dart, and we are going to create first a class shop order. This is going to hold a price, and also each and every entity that's going to be used within ObjectBox database needs to have a field called ID of type int, so int ID. This is an absolute necessity. Then, as you can see, beside the ID and the price, there should also be a customer name present on the order, but we are actually going to handle that via a relation to another entity, which is going to be a class customer, right? So we're not just going to put somehow a string customer name directly into the shop order. No, we're going to point to a customer entity inside the database. We're going to handle that later. For now, let's just focus on all of the fields besides those ones which represent a relation. So these two fields are then everything besides relation fields, which is going to be on the shop order. So let's now create a constructor, right? We're going to create shop order, and then these are going to be named parameters. So we would say required this.id and required this.price, right? Yes, I mean, this is kind of valid, but actually it's not our job to populate the ID. It's the job of the ObjectBox library to populate it whenever this data is stored and read from the database. So we don't need to make this ID a required parameter. It can be optional, and then we're going to provide a default value of 0 whenever we do not specify this ID ourselves, when we are instantiating a shop order from our app. But this ID again will be populated by the ObjectBox package. Every entity needs to be annotated with the @entity annotation, which comes from ObjectBox, so that code generation is going to recognize that this class is actually an entity and that it should generate code for this class. Let's actually kick off code generation. So we're going to use our most favorite command, which is Flutter. Let's first clear this and Flutter, pub run build runner, watch, and run that. You can also copy this command from the written tutorial, and the code which is going to be generated by ObjectBox generator is always going to be at the root of the lib folder right here inside a file called objectbox.g.dart. Of course, we need to first save the entities files for the g.dart file to be generated. So here it is. And also we have just generated objectbox model.json. So this JSON file is used from the ObjectBox Sync for syncing data between multiple devices, which I'm going to demonstrate toward the end of this tutorial. And then the objectbox.g.dart is simply used within our local database. If you're putting your project to source control, which you probably are, it's quite important to keep this objectbox model.json in your source control, so you want to check it in. But as for the g.dart file, as is kind of usual with generated files, you do not want to put them into source control. So let's actually just go to git ignore, and somewhere around here, maybe all the way down, I don't know, here in Flutter.dart pub related, we're going to say that we ignore anything that is .g.dart. Boom. And now this objectbox.g.dart will no longer be checked into source control. But this objectbox model.json is going to be checked. That's quite important. So let's now also create the customer entity. So add entity, and it's going to contain int ID, then string name, and it's also going to have a constructor customer. Let me just actually use a Dart data class extension in VS Code. If you don't have it and you are using VS Code, I highly recommend it. Dart data class is the name of this extension, Dart data class generator. And you can always copy the code from the written tutorial. So again, this ID doesn't need to be required, and we are just going to set it equal to 0 by default. And now we have both the shop order and customer entities. So what about the relation between a shop order and the customer? Well, when you think about it, an order will always belong to only one customer. If I go to the app, which is already running on this device, every order has only a single customer. But as for the customer, a single customer like this Vern Dibbert right here can have multiple orders. So the relation is one customer to many orders, and reversely many orders to one customer. We're therefore going to use a to-one relation and a too-many relation. Other kinds of relations are also possible within ObjectBox. For them, you should check out the official documentation of ObjectBox, which is linked in the written tutorial. So a shop order is going to have a relation to a final customer, and this relation can be signified by writing to-one and then specifying the type. So customer is the type of the entity that the shop order has a relation to. So this is how you define a relation to one entity, in this case customer. And now the customer is related to many orders. So we're going to create final orders. And here we are going to say too many, because a single customer can have many orders. Too many orders, right? Too many shop order. Also, we need to provide a add backlink annotation for this orders too many relation, because this tells the entity that the orders made by this particular customer will be gotten or backlinked or populated by looking at the to-one relation inside the shop order class. These relations are going to allow us to easily get customers' orders and also get the shop orders customer without needing to query the database ourselves for it. This kind of related data is just going to be available to us easily. Now that we have the data model done, we have the shop order and customer entity classes fully finished. Let's now go to homepage.dart, and here we are first going to create a store. In ObjectBox, you access all of your data on a store instance. But before we can access the data and write something to the store, we first need to initialize that store object. We're going to do so from within initState. So we'll want to store this store object inside a late store underscore store. Let's import store from ObjectBox.dart. And now let's edit this initState. So as you can see, right over here in initState, we are already calling setNewCustomer immediately when the app is initialized, so that right when the app starts, we're going to have a customer ready for whom we can begin to add orders. And below this setNewCustomer call, we are now going to initialize the store. So we are going to write store is equal to store. And now this store accepts something called a model definition. So where in the world are we going to get this model definition? Well, this comes from the generated file, so we do not need to worry about creating this model definition ourselves. We just need to call get ObjectBox model, which if we go to the location of this method, which we are calling by hitting F12, we're gonna see that it indeed returns a model definition, and it is inside the generated file. And then what's also important is to specify the directory for the store. So this directory will need to be the application documents directory that we can get from the path provider package. Provider package, therefore, we need to call get application documents directory. This is the directory that can store persistent data. It's not just going to get cleared for any reason. And this returns a future directory. So we would usually await this. But since initState cannot be made asynchronous, really, what we are gonna do is instead of awaiting, we are going to use the then continuation, which is going to pass us a directory dir. And inside of this continuation, let's make it into a block body. We're going to initialize a store from within this continuation right here. And the directory can be gotten by joining the directory, so dir.path with slash some name of the database file where we should store the database. So let's just say ObjectBox. Actually, even though we have not imported manually the path package, which allows us to safely join to paths no matter the operating system we are running on, because on some operating systems the ways of joining a path may be different than just a /. So even though we are not directly depending on path, we can actually import package path/path.dart, and instead of doing this directly like an interpolated string, we can instead say join right here. So join, and we want to join dir.path with ObjectBox. Much better. Also, whenever you initialize a store like this, you should also close it. So inside a dispose method, we're going to call store.close. Lastly, because this is a late variable, but this store is initialized only once this feature has been successfully run for getting the application documents directory, we need to have a way to find out if this store is already assigned, because otherwise we are going to get the error of accessing late field before it's properly initialized. Sure, we could make this store nullable and then check only if the store is not null, in which case we would not access it, but we do not want to introduce nullable fields to our app unless necessary. So to mitigate this issue, we can remain working with the late field, but we also need to create a boolean has been initialized and set it equal to false by default. And now whenever the store is initialized already, we're going to say set state and set the has been initialized to true. Let's now take a look at how we can set the customers properly and add orders to the database. So we are going to be able to set sort of the current customer for whom we are adding orders, as you can see right here, by pressing this button, by which the name of the customer and the whole customer for whom we're adding orders changes, and then we add orders for that new customer. In this case, it's Kayla Stam or Stam, I guess, if you want to pronounce it like an American. So we can do this and then change the customer, and now the new customer is going to be Angel Flatley. So it's kind of obvious that we are going to need to access this current customer object, which is going to be, of course, of type customer entity right here. We're going to need to be able to access this object from the add fake order for current customer method. So we need to keep this customer as a field inside our state class. So let's do just that. We're going to create a late customer underscore customer. Let's import customer entity over here from entities.dart. And we are already calling set new customer whenever the app is first initialized, so that's good. Then we are also calling set new customer whenever we press this button, but currently this set new customer method only prints out the name to the console. So we want to change this. We are going to instead say customer is set to a new value, which is going to be a customer, and we're going to populate the customer with a name from faker.person.name. Again, we do not populate the ID. That's the part that ObjectBox is going to do. Once we have this customer field inside of our state class, we can add fake order for the current customer, right? This method is called from the other action on the app bar. the one with the dollar icon. So over here, we're going to create an order first. Final order is equal to shop order. We need to set its price directly in the constructor. So the price will come from this faker random generator integer between 10 and 500. Cool. And now we also need to set the customer for the order. We only need to set the customer relation for the order, because when you take a look at this, the orders to many relation is actually backlinked to the shop orders customer relation. So as long as we set this customer to one customer relation on a shop order, the other relation on the customer entity is gonna be automatically handled. So we only need to set a customer associated with the order. That's it. So how can we set that? Well, we cannot just pass it to a constructor because we don't have any customer parameter in the shop order constructor. Instead, we need to access this customer field on a shop order object that's already created. So let's say order.customer. And now we want to set this target for this relation. So target, and we're going to set it equal to the customer, which is currently set as being the current customer in our state. Lastly, this is where we are going to persistently put this shop order into the database, and we can do that by saying store. Then each and every store has multiple boxes. We're going to have one box per entity. So since we are operating with the shop order entity, we are going to access the shop order box. And on this box, we want to put the order object or the order entity. And although we're only putting the order into the database, nowhere are we calling store box customer put, still the customer is also going to be put into the database if it doesn't exist yet inside of that database. So if we go here to our iOS simulator and I create a new customer and now add the first order for that customer, this customer, Malcolm Curlin, is gonna be added automatically to the database just by calling store box shop order put. Then if I subsequently call add fake order for current customer more times like this customer already exists in the database, so it's not gonna be added there newly. We're just going to point to the already existing customer entity in the database from all of these new orders that we are adding. There is more to relations and how the data is added and how you can update data within relations than I have just mentioned here. And the documentation of ObjectBox is really awesome in this regard. It explains everything very clearly, and a link to this ObjectBox documentation about relations is available in the written tutorial. But as for our app, this kind of a basic knowledge about relations is completely enough. So now we have the putting of the data into the database completely handled, but it's of no use because even if I were to press these buttons and add orders and such, we would still not see anything displayed in the UI because we are not displaying anything from the database. So let's now handle that. We're going to watch the data. It's possible to perform a one-off read with ObjectBox, but in a reactive framework like Flutter, it's almost always better to continuously watch the data using a stream. And this stream is going to produce a new event whenever the data in the database is updated. For example, we're automatically going to receive the new orders when we press this add order button. We're gonna need to rebuild the UI whenever a stream produces new events. So we're going to wrap this order data table that should display that data inside a stream builder. We can actually do so right now. But before we do anything meaningful with this stream builder, about which we're gonna worry about later, we need to first create a stream field in our state object. So that's gonna be a late stream that's going to hold a list of shop orders. And let's call it _stream. We are gonna want to start watching the database for the basic unsorted data right when the app starts. So we're going to first set this stream directly from within init state, and then later on we are also going to set this stream with some sorting enabled whenever this onSort method is run on the order data table. But for now, we are just going to worry about the non-sorted data, just the basic data coming out of the database. So inside init state, as soon as we have initialized the store, we're going to come into this set state method, since we need to, well, set the state to rebuild the whole UI of this stateful widget. And we're going to assign the stream to be equal to store.box of shop order, because we want to watch the shop orders after all, shop order. And then we want to query this shop order box. And this is the simplest possible query. We are not specifying any query conditions here, but you can really do a lot with ObjectBox queries. We could, for example, do something like query where shop order with an underscore at the end dot price dot is null, or for example, price is greater than 200, right? We could do things like this, but we're just going to query for all of the shop orders regardless of their price. So we're going to keep this query this simple. It's going to be empty. And then we're going to say dot watch, which is going to produce a stream of query shop order. And we also want to set trigger immediately to be true, so that we get this data as soon as this watch method is called, and not only when some sort of a new data is produced. So trigger immediately is true. All right. And this stream is currently of type stream query shop order, but we actually want to have a stream of list shop order. So we need to actually transform these queries to an actual list of shop order data. So we're going to map this query stream, which passes us queries, and we are going to say query dot find, and this is going to produce the data we are after. So now that everything is formatted, you can see nicely that we are calling store box shop order, then we call query with the simplest possible query for getting all of the data. Then we say watch, which is going to produce a query object whenever the underlying data changes. And then, since we actually want to get the data, we say query.find. Now we can finally worry about displaying all of this data. So the first step, even before we mess with this stream builder, is to actually be able to pass in the shop orders into the order data table. So how can we do that? Well, we of course need to go into the order data table file and create a field on this widget that is going to be of type list shop order. So let's create final list of shop orders, and let's call it orders. Let's add this as a required parameter to the constructor. So this dot orders. And once we have it available in the widget, we can finally go down to the data table, and we are not going to touch columns because these just define the column names and the number of columns, but we are only interested in these rows, which is where the actual data is going to be displayed. So we do not just want to hard code multiple data rows in here. We actually want to produce these data rows, the list of data rows, right, by mapping the list of orders. So let me just cut out all of this whole data row, right? Cut this out into your clipboard. Now we can remove this list literal, and we are instead going to say widget dot orders, which is the orders list. And now we want to map each and every order of type shop order into a widget, which is going to be that data row. So let's return data row. So let's just paste the content of the clipboard here. Boom. And now, of course, since map returns iterable, we need to call toList, because rows needs a list, non-lazy list to be more precise. So we're going to say that toList. Boom. And lastly, this should of course not contain the hard-coded things like hard-coded ID in all caps string, but instead it should display the actual ID, which we can get from the mapped order dot ID and then convert that to string. Similarly, for the customer name, it's not going to be hard-coded customer name in all caps. Instead, it's going to be gotten by calling order dot customer dot target, because we want to get the target to which the relation points, and then this is a nullable field, so we need to access all of its data safely, but still we can get the name of this customer. And if it's null for some reason, if this relation is not populated, we're just going to handle it by displaying none. But this is never going to actually happen in our app. This relation is always gonna be populated successfully. As for the price, we have this escaped $sign here, so that's nice. And then we also want to have interpolated order dot price. And lastly, we have this delete icon. We're just going to leave it as it is for now. We're going to handle the deletion later on. So now we can worry about the stream builder in the home page, because from it we are going to pass the actual list of shop orders into the order data table. So this stream builder will work with a list of shop orders like this. The stream is going to be the underscore stream, which we are currently setting inside init state right here. And even before this data from the stream arrives into this stream builder, we first actually need to check if the store has been initialized, and if it has not been initialized, so not has been initialized, instead of displaying this stream builder and the order data table, we're going to display a center widget. So let's say center. If I provided the proper syntax for ternary operators, so a question mark goes here. And now center's child will be circular progress indicator. So whenever we are still initializing the store, so we have not yet gotten the application documents directory, we're going to show a circular progress indicator like this. Otherwise, if it is already initialized, we can start showing a stream builder here with the order data table. But even inside this stream builder's builder method, we need to check if not snapshot dot has data. So if it hasn't got any data, we're again going to show a center circular progress indicator. So let's return that. Of course, this is code duplication, but for these kinds of simple example apps, this is completely fine. And well, as for the order data table, we need to pass in the orders, which is going to be a list coming from the snapshot from the stream builder .data, and this data is nullable, but since we have already checked that the snapshot must have data if we are displaying this order data table and not this circular progress indicator, we can just do a exclamation mark here to tell Flutter and Dart that we are sure the data is already here and that it's not null. Boom, and just like that, I have now saved the app, hard reloaded it, And we see this circular progress indicator in here. If we take a look at the console, maybe there's going to be some error, or actually not. So that's cool. Of course, there is currently no data coming through the stream because the database is completely empty. I have not yet pressed any buttons. So when I just create a new customer here and add an order for that customer, nothing's really gonna happen. So let me just hard restart the app. That usually solves it because we've been doing a lot of changes around here. So hard restart that, boom, everything is now visible nicely, that's good. And we can now add a new order. And it's immediately visible here. So Krista O'Connor, change the customer. Now the customer is Rayleigh Showalter. These names are killing me really, but everything is visible. So now we can already display the data and add it to the database. And this is the core stuff that you can do with ObjectBox, but of course ObjectBox provides you with much more functionality, like proper querying of the data, which we are actually not going to even do in this tutorial. But what we are going to do is, for example, sorting the data, because whenever we press this ID column or this price column, as you can see, the arrow direction changes, but we also want the sorting of the data to change according to the price or according to the ID, either ascendingly or descendingly. So we already have this onSort callback on our order data table. And if we take a look at its implementation, right, it's called whenever we press on the ID column or on the price column, we call onDataColumn sort. And here we simply set the local state of the order data table so that this arrow orientation changes, basically. And then we call this callback function, passing it the column index which is pressed, and then whether or not the sorting should be ascending or descending. So we can use this column index integer and Boolean ascending values from our homepage.dart to create a new ordered query on our database. So let's do that. Since this query will be a bit more difficult than just this simple one here in set state in init state method, we're going to separate it into multiple variables, and we are not just going to write it all inline like this. So let's just first create this kind of a query. We can actually copy this bit. So store box shop order query, copy this, and inside this callback function onSort in our order data table, we're going to create final new query builder and set it equal to this copied value. Boom. Now, in order to sort this query, we are going to need to call new query builder dot order, and this order takes in the property based on which we should order the data. So this is actually gotten by calling shop order underscore, which is the generated class, sort of a companion class with our actual shop order entity. And on this class, we can access, for example, the ID. And now the data will be sorted based on this ID, or also price. And now the data will be sorted based on this price. This price is of type query integer property. So you cannot just say shop order.price and pass in the actual integer here. You need to pass in the shop order underscore.price, which is not an integer, but instead a query integer property. So this is the generated class. But we cannot just say shop order.price or shop order.id, because we're gonna sort based on a different property depending on the column index which is passed into this callback function. So we're going to create a final sort field and set it equal to a different value based on the column index. And if it is 0, which means this ID right here, because this is 0 index, in our data table, then we're gonna sort based on shop order underscore dot ID. And if it is not 0, it means that it must be 2, because this price is on the second index, and this is the only other column based on which we can sort, which we can press, because for example we cannot press this customer column, only ID and price columns are pressable in our data table. So we know that otherwise it's gonna be sorted based on shop order dot price. So shop order underscore dot price, right? And now we can specify it here. So new query builder dot order based on sort field. And also we need to specify whether we are gonna be sorting ascendingly or descendingly. So usually you would specify flags, and if you leave it either unspecified like this, or you say that the flags are 0, you're going to sort ascendingly. But we need to base this value upon the ascending boolean coming into this callback function. So if ascending is true, we're going to leave the flag to be 0. If it's not true, we're going to set it to order dot descending. You can do very many things with this flags parameter on the order call. You can combine multiple flags like order descending and then also or order dot case sensitive. So you can really play around with your ordering or sorting of the values from the database, but for us we can just keep it this simple. Link to the official documentation about ordering and all of its intricacies is in the written tutorial. And once we have this query builder all set up, we can again call set state and set the stream to a new stream, which is going to be gotten by calling new query builder dot watch again. And we want to trigger immediately set to be true, much like in the init state method. And then we're going to say map, and we want to map individual queries to query dot find. Again, this is the same as in the init state method. And so now what I can do is to tap on this price, boom, and now we're gonna sort based on price, as you can see, right? And also based on the ID ascendingly or also descendingly. So this is amazing that we can do that this simply, and it all just works because we are using reactive queries which ObjectBox provides. Now let's handle deleting the individual orders, which is going to be very simple to do. So much like we can put a new shop order into the database, we can also remove it from there. But for that, we are going to need to be able to pass in the store into the order data table. So let's go to order data table and just create simply a field final store, populate the constructor with it, boom, let's make it required. And then right here, after we import store from ObjectBox.dart, we can just scroll down into this last data cell, which has this to-do comment that we should delete the order from the database. And all we need to do here is to just call widget.store.box, and we're going to select the shop order box. And it's as simple as calling remove, and then we need to provide the entity ID which we want to remove. So we already have the shop order entity available based on which we are building this data row. So we can just access order.id. And now after we go to the home page and pass in the store to the order data table, so all the way down here, let's say store is equal to _store. Now I can delete, for example, this second order, the one with the ID 2, by pressing here, and it's deleted. And now we have only orders 1 and 3. And of course I can add new ones for a new customer easily. And then also delete them. Easy. But if we have multiple orders for a customer, it would be nice if we can just click this customer name and then show in that modal bottom sheet, as you can see in the already finished app here, to display all of the customer's orders like this. We already have all of the relations set up to be able to do this very easily. All we need to do is to actually show and populate this bottom sheet right from the order data table data cell for the customer. So whenever this data cell is tapped, we want to show the customer's orders. Let's do that right now. So I'm just going to show modal bottom sheet. We need to pass in the context and then a builder for the modal bottom sheet, which is going to grant us a build context. How else? And now from this builder, let's just return something very simple. So we need to provide a background, somehow white background. So let's just return material. And this material is going to wrap a child, which is going to be a list view. And this is going to be a very simple list view with children specified on it directly. And the children are going to come from order dot customer dot target. So we have the order available, which we are pressing right here. So we need to get this orders customer first, and then on this orders customer, we can then access, unsafely for now, all of the orders. So we are using all of the relations which we have set up. We first use the relation to the customer on the order. And once we have this customer already, we then get all of the orders from this customer using the toMany relation. And this orders is really of type list, although it's not really a list, as you can see in the entities. It's of course the type toMany, but when we take a look at toMany by hitting F12, it is mixed in with the list mixin, so it does behave like a list. So therefore what we can do is to just call map on these orders. So let's say orders.map, and now we can map all of the orders. Let's just call it underscore for shortness. So this underscore is the order which contains the customer ID and price. And let's just create a simple list style here that's going to contain a single title, and this title will be of type title will be of type text, and this text is going to hold all of the data simply concatenated like an interpolated string. So firstly it's gonna be the order, so underscore.id, then let's put 4 spaces here, then interpolate underscore.customer.target, and then safe access name. And lastly, again, 4 spaces or something like that, and put here interpolated price, so underscore.price. But since we want to show the $ symbol before the price, we're going to escape a $ symbol before that interpolation. Boom. And all we now need to do is call toList after this map call. And that's it. So now when we press on any kind of a customer, we're going to see a modal bottom sheet displayed with all of the orders from that particular customer. So Henry Langosh has these 2 orders. Curtis Fisher has these 4 orders, and so on. Rayleigh has these orders. This code is sort of badly visible because it's just, it's just cramped in here. But if you want to get it and read it at your own pace, you can always do so from the written tutorial. Now, let's finally take a look at how easy it is to synchronize data between multiple devices, because currently all of this data is just present on this single device or on this single emulator in our case. But you can also use ObjectBox Sync, connect it sort of to your local data, and then that ObjectBox Sync is going to handle everything regarding synchronizing it on all of your different devices. While the local database is completely free and open source from ObjectBox, and it's always going to remain free and open source, the ObjectBox Sync is a paid product of ObjectBox, and it's a really great way to keep your data synchronized across multiple different devices, and it's a great alternative to things like Firebase, for example, or some AWS services, because with ObjectBox, it's absolutely simple to synchronize data. You just basically run a single command, do a little bit of configuration, and your data is synchronizing just like that. And also, you are fully in control of your data. You run ObjectBox Sync on your own servers, so that's also a huge plus. So if you are interested in syncing your data, definitely go to objectbox.io/sync. Link to that will also be in the video description, and you can get a free trial of it. And then also you see all of the different kinds of sync that are available, and you can also just contact the ObjectBox team and they will set you up with the solution that you need. To use sync, you will need to have a sync server file. I'm going to be running it on Docker. You probably don't have this file just yet unless you have contacted ObjectBox. So unless you have it, you are probably not going to follow along with this last part of the tutorial, but it's still cool enough so that you should stick around. So right here on my Mac, I have the sync server file here downloaded. This file can be used with Docker, which I have running in the background already. I have now restarted Docker so that I can remove this image so that I can show you how to edit anew. So once you have this file available, it's completely easy to add it to Docker. So I'm just actually gonna do it from command line. Let me open up a terminal here in this folder. So I have sync server available right here. And all I need to say is docker load input, and then since we are in the same directory, I'm gonna say /sync server.tar. As easy as that. And the image has been already loaded. So when I go to Docker, we can see this image right here, right? And now, of course, you can be more elaborate about where the data is gonna get stored. You can create a separate Docker volume for the data, but we are not going to worry about that in this showcase. We are really just going to kick off this Docker image and make it store the data directly inside of this Flutter project. So right inside of this VS Code, I'm going to open up terminal, create a new window, and I'm gonna paste this command here. All of this is also available inside of the documentation for ObjectBox, which looks something like this. So literally everything you need to know is inside of this documentation on the ObjectBox Sync server. So what is this command doing? Well, it runs this image, which we have just added to Docker. We are not using any authentication to secure our data, but you have the option to use Google authentication, or you can also use a shared secret. All of that is available in the documentation on how to do that. And we are going to be running this on localhost port 9999. So once I run this, It's not gonna work because we need to most likely remove this space that was added in here for some reason. So let me do that. Boom, easy. And also what's important is that you are going to pass in the ObjectBox model.json file, which is generated from your entities, because this is what's being used by the ObjectBox Sync server to actually sync all of your entities properly. And for now, all of the data will be stored simply in the data directory directly in our root of the Flutter project. But of course, this is all configurable. You obviously do not need to store your data in the root of your Flutter project because this is only useful for development purposes, obviously. Let's now actually delete all of the spacing after the forward slash or backslash right here. All right, so now this should work kind of. All right, so this is just something weird with formatting. So I really am not sure why this is happening. Of course, this will not run, but let's now clear and paste the single line representation of the very same command, but I just removed all of these slashes. So now it's just a single line, and now it should work actually. Boom. And yes, it is working. So ObjectBox Sync server started in 85 milliseconds. It wasn't even painful, just somehow the backslashes caused some trouble previously. So now this is running. And all we need to do now inside of our Flutter app is to go to pubspec.yaml and change the dependency ObjectBox flutterlips to ObjectBox Sync flutterlips. Save that. The version is gonna remain the same. Now, since we have just run flutter pub get, we need to rerun our build runner. So let's do that. And let's just also include delete conflicting outputs for good measure. And we can now go to our entities.dart file, and we now need to mark them as being synchronized. So we're going to mark it with @sync annotation. The same goes for the customer entity. So it's easy as that. And now inside homepage, where we are initializing our store and everything like that, once everything is generated, it's just going to run properly again without errors. Here we go. Now we need to do just a little bit more setup. We also need to have a late sync client field. Let's call it sync client with an underscore. And now, after we initialize the store, we're just going to say if sync.isAvailable. We of course need to import sync, but we cannot do that for some reason, but is available. Like that, all right, now it works. Then we also need to set the sync client equal to sync.client, pass it the store, pass it the server URI, and also credentials. So let's first handle credentials, since we have specified in the command, which you can see right here, that we are not going to use any credentials. We use unsecured no authentication. We're therefore going to pass sync credentials dot none here. And as for the server URI, I'm now running this on a localhost Docker. So I need to point to WebSockets, so WS : / and now it's going to be 127.0.0.1, and the port is 900 or 9999, like this, because again, this precise IP address is available right here. So we are publishing to 127.0.0.1 and then port is 9999. And then all we need to do is say sync client.start. And you can also do a bunch of more things on the sync client, like you can, for example, cancel updates and do all kinds of stuff, but we are not really gonna do that. And also it's probably good to call sync client.close from the dispose method. So let's do that, sync client.close, to release all of the resources. Now, this IP address is completely fine and it's correct. It's going to work for iOS simulator, but for Android, there is actually a special IP address when you try to point to localhost. So if platform is Android, we're instead going to have here ws://10.0.2.2, and the port is going to remain the same, so 4 nines. And now it's going to work also on Android and on iOS the same way. I now need to stop running the app on my Android emulator anyway, because we have added or changed a native dependency, which is a plugin. And in that case, you always need to stop your app from running. But also, we have changed our entities to be synced, but previously they were not synced. If you do something like that, you actually need to wipe your app's data. If you already have an app in production, not only in development, and wiping the data is not an option, whenever you change the previously non-synced entity to be synchronized, there are ways to do it, and everything is available in the documentation. You can sort of migrate your data to another entity which is going to be synced. But in our case, it's completely fine to just go ahead and go to ObjectBox tutorial. Hopefully it's this one. Nope. Go to ObjectBox tutorial and just go to storage and cache and clear storage. Boom. And now I can run the app on Android again. So let's launch that. And in the meantime, I'm also going to call flutter.run and select the iOS simulator, which is running also on my machine right here. So I'm going to select the number 2 for iPhone 12 Pro. And once everything will be running, we're going to see the data synchronized between these two devices. And all it took to synchronize this data is really just 2 commands and just a bit of setup client side inside our Flutter app. But apart from that, we didn't do really much, and the data is just synchronized. So that's awesome. Of course, there is no data currently inside our Android app because we have just wiped the data. So we need to add it anew. Let's just wait for iOS to also build. Here we go. And now on Android, I can add a new order, and boom, it's also going to appear on iOS. Similarly, on iOS, I can add a new order, and boom, it's going to appear also inside our Android device. Just like that, it's super fast and super easy to implement, and I can also sort based on price, sort based on IDs, and everything just works just as previously. So that's completely awesome. And this is it for this tutorial on ObjectBox. You have seen how to build an app dealing with orders and customers, and how to represent this data in the ObjectBox database. You've learned about entities, about relations, about ordering the data, about how to perform reactive queries, and you have probably also learned something about data table widget, I guess. At the end, I've shown you how easy it is to synchronize your data across multiple different devices with ObjectBox Sync. So again, if you are interested in Sync This is a paid service which ObjectBox provides, and be sure to contact ObjectBox, and they are surely going to help you out with any kind of synchronization needs that you have inside of your app you're building. But of course, data synchronization is only an additional step that you can do with ObjectBox, but it also works completely fine and completely for free as a local database package. And it also shines in that regard because it's completely fast, it has relation support, so it's very nice to work with inside of your projects. To go through this tutorial at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education. Link is also in the video description, by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this, be sure to subscribe to the channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am just determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, be sure to give it a like, leave a comment if you have anything to say, and see you in the next video.